All right. Join me in giving a round of applause for our live speakers, Sydney and Brian. Take it over, gentlemen.
Thank you. We can just hand it off. Thank you. All right. Thanks, everyone. Is this coming through? Can you hear me? No? Louder, louder. Closer, closer. Okay. Yeah, I won't do an auction here. So thanks everyone for your time and attention. So obviously, Brian and I, work with the other folks from Elemental here, and we've been working on a project here to with the VSF around modernizing cloud connectivity, and so making it easier for people to connect devices to the cloud. So we thought let's bring this to our friendly audience here and see what you guys think. So first, a little bit about us as presenters. So like you'd introduced me, I'm Sydney Lovely. I run the Media Connect service team for AWS. Thank you. So before that, I was head of engineering at Grass Valley for about 10 years. So see a lot of familiar faces here. And then before that, I was at Harmonic for a spell as well. So I've been in the industry for just a bit of time. With me is Brian Rundle. Brian's the real star of the show here, so I'm just his introductory act. Brian also, of course, has been at AWS Elemental for a while. Before that, he came to us from Intel, and even before that, he came to us also from Intel. I had to dust off the old Intel logo for you, Brian. So a word about Elemental. So a lot of folks here probably already know this, but there are some new faces, so I thought I'd not make any assumptions. So AWS Elemental is a group within the greater AWS organization that focuses on media workloads. So a lot of this is distribution oriented. So there are 5 main services that Elemental offers that help live and file-based workflows handle distribution paths for customers. So this is a simplified diagram of what a customer may want to do. So bringing in a live signal, ingressing that into the cloud. That's a big part of what the Media Connect service does, which is our service. That would then get handed off to our AWS Elemental Live, which is a live transcode engine. Similarly, customers would bring in VOD assets or file-based assets and use maybe Media Convert to conform that, store it in S3 storage. Use the packaging service that Nicola's involved in, using from there through our media tailor service for ad insertion, then off through a CDN to CloudFront. So the earlier talk tonight was all about the right-hand side of this diagram. Our talk's going to be all about the left-hand side of the diagram. So a few things around Media Connect and typical Media Connect use cases that we get involved in. So as I mentioned, a lot of times customers are using this for ingressing into the cloud or egressing into the cloud. So they might set up a virtual private cloud with compute workloads doing various applications like graphics or live production. They also use Media Connect to do cross-region transfers. So it's very common for them to take something into like the US West region, send it to US East, send it to Dub, et cetera. And then also cross-account workflows where folks might take produced content and then send it to an affiliate for distribution. So those are typical use cases that Media Connect's involved in. And one of the things we commonly hear from customers is that oftentimes the hardest part of this whole workload, right, seems pretty complex, right? It's setting up VPCs, sending things cross-region, sending things cross-account. They actually tell us oftentimes the hardest part is the left-hand side of this, connecting ground devices in the first place. So why is that, right? So when you look at the diagram on the right, and this is just an overly simplified diagram, but customers have an on-prem network, right? They have a myriad of different types of transport protocols to choose from today. So a lot of the focus in the industry has been around transport, things like SRT or TR07 or RIST. So all of those, there's tons of good protocols to choose from that will give you reliable, secure transport itself. However, you still have to manage all of the networking rules. So you have to be able to understand the fact that I've got a private IP address. I'm going through a firewall and NATing to a public IP address. I have to set up security group rules for my VPC, et cetera. And a lot of that is pretty complicated for customers, especially folks who are maybe operating on-prem equipment that are just trying to set up a live production. They're not networking experts. Our premise here is that by leveraging modern IoT technology, we can eliminate a lot of this complexity for customers and allow them to connect devices on the ground, whether they're ingress or egress, by using a simple pairing code process. So this is something that Brian's been working on now for a year or two. And we've started the process with the VSF. So the VSF is an industry kind of quasi-standards body called the Video Services Forum. They are the ones that do the TR-specs, like TR07. And we started working with them in the fall, and we're now in kind of a draft stage for a TR proposal. So the notion here is to release an open source and public SDK along with a TR draft proposal. So this would be a fully open thing, not an AWS thing, but something where a customer could take that SDK, integrate it into their device alongside like the SRT, transport SDK, and it would give them the ability to discover, authenticate, and connect devices on the ground with a very simplified process. So with that said, I'll hand it off to Brian to take you into some of the details of it and a live demo.
Really close. There we go. Okay. Before I do the demo, I wanted to just expand on some of those pain points that we have now for the left side of the picture there, where you're getting video into the cloud. It looks a little, at first glance, it seems simple. You need some form of control to penetrate a firewall into the device, LAN, and video to get out. In reality, though, it's quite a bit more complicated, and this slide just captures the fact that there may be a cloud operator involved, and an on-premise operator for the devices, and possibly even a network admin if you have access problems. And the act of going from the cloud through the VPC involves keeping track in a spreadsheet or however it's done to tunnel into the VPC, know what the device IP is, have certs to log into the device and start to configure it. And then that's replicated across all your locations that might have different VPCs and different IP addresses. So it might look something like this. There's 3 phases. There's going to be an initial setup phase, and then a running operational phase, and then maybe a teardown phase. So you're going to have to get your VPC credentials, tunnel into the facility where the device is sitting. A little bit of a delay here. Get credentials to the device. This is just the setup part. I'll just. So things can happen along the way. So you forgot to set up your cloud endpoint, and you're already VPC'd into the region. So you got to get out of the VPC so you can get back to your cloud resources, so your email starts working again, and all the other things you want to do. So you're constantly going in and out of this mode. So you got to log out of the VPC, set up the cloud endpoint, tunnel back into the facility. And then if you're setting up an encoder, you might have to copy all of the transport stream parameters to that device. So if you're the same operator, you can maybe copy paste, but you might be on the telephone doing this. And that's really fun when you're talking about like an AES protocol and you're communicating a 32 character string A10LIO. And then you can log out of the VPC, and you're at the running phase now. So maybe a couple days later, after you've set it up, you want to start running it. So you got to go back in the VPC, but the device IP changed, so you call the network administrator. Finally, you start the device. So that's the sort of pain we're talking about. Now, when you get done with this, you still have a problem that you don't really see that device unless you're in this condition where you can actually see the device. So if you want to monitor your whole video workflow from one cockpit, it's a little hard when you can't see what's happening on the device. So that's another problem with this workflow. And finally, that setup's not portable. So if you move that device to another location, you got to go back and do everything again. And then tearing down, it's more of the same. So we envision a simpler process, and this is what I'm going to demo tonight. You basically need access to the device to get this process started, but it's a one-time operation. You'd think they'd get PowerPoint by now. would be a solved problem. I used to do animations all the time in my Intel presentations.
Yeah.
This is why we don't do it anymore.
We're not really a PowerPoint.
Yeah, we're not
culture
really a
at
PowerPoint. I haven't done this for years. So then you go, and I'll show you this. It's a pairing process. So much like when you're connecting, Netflix to your account, you get a pairing code presented to you. In this case, the pairing code's presented on the device. You don't have to type anything in the device or have an interface to the encoder other than just look at a 6-character code. And then you communicate that code to your cloud operator, maybe it's the same person, and then you use it to claim the device. So that's a one-time operation, and it's portable for wherever you want to power down and move that device. It's still connected to the cloud. I'm about to abort the... There we go. Okay, so when you want to run the device, you might want to edit some of the AV settings, like the encoder setting and bit depth and stuff like that. So the system that we have lets you do that. So the SDK allows a device integrator to specify what parameters they're willing to expose to a cloud operator. So we think there's a subset of encoder settings which are fairly common and sort of the hit list that will be part of the protocol. And then it's just a matter of assigning that device to a cloud endpoint. You don't even really need to, from the services side, set any of the transport stream parameters because that can be done automatically in the cloud and push to the device. So you don't have to set IP addresses and ports and keys or anything like that. That can be handled by your cloud automation and just send those settings to the device. Tear down, you just hit revoke on the cloud service and you're done. So the demo that I'm going to show you today, I have an encoder device sitting at the AWS HQ. I'm going to interact with it to do the pairing process. I didn't want to bring it here because network stuff, a little harder to do. So,
sorry, did you mean an encoder or an encoder?
oh, this was the, I gave this slide to you, and then I fixed it, and then you gave it back. Thank you.
Very French.
Very.
Thank you, I appreciate that. Lionel also, Lionel.
What are you talking about? Okay, so this is a snapshot of a Media Connect console that currently is disconnected from anything kind of streaming to it. It's just an endpoint that we've set up in the cloud. It's set up to be an SRT listener. And as a result, there's a bunch of parameters here that are set in configuration for encryption and that kind of thing. So this is the interface to that device that I showed you that's sitting back at the office. And I'm using the AWS VPC right now to look at this control console. So I'm really looking at the web console from the device. But remember, I just have to do this once. So I've integrated the SDK into this device. It's an Osprey Talon encoder and made a few changes to the web code and the JavaScript code for the console application and did a sort of an early integration. So it's a little rough, but it should work perfectly in this demo. So this is what you see. This is all you need to interact with to do the setup. So right now the connection is disabled. You can select a host service. So right now I've built one in AWS, so you can select the AWS service, but like Sydney said, whoever wants to abide by the protocol and launch their own web service, and that could be available too, as long as the device integrates that little JSON file on their device. So let's do the pairing. So I'm going to enable it, and right now it's contacting the host. The device knows that it doesn't have any credentials at all, and so its initial connection is going to be through pairing. The API is really simple, and it doesn't involve a lot of intelligence on the client side. So here's a pairing code. And this console that I'm showing here is a very rough mock-up of the AWS Media Connect console when this is built in, right? So what we see here is a pairing window. In blue, these are going to be the list of all the devices that are on in my repository that I've paired. And then over here, various status windows for things like system and input and channel and that kind of thing. And then below, I've just created up a mock-up of a configuration widget. top of the right code. There we go. Oh, it didn't paste. There we go. So it takes a few seconds, and now it's connected. So what essentially happened is I claimed that device. I typed in that 6-digit pairing code, and meanwhile, the encoder itself had been polling the AWS endpoint and saying, has anybody claimed me yet? And in this case, the answer was no, 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 and finally it's yes. And then it's given an identity, it's given X509 certs, the whole sort of OAuth 2 process. And if I look in the cloud here, now I can see all of the status from the device. So I'm populating just a minimum of windows here, but oh, that's terrible. System status information, things like temperature and memory and that kind of thing. Input status, this is the state of the HDMI or the SDI input. And the status of this is single channel device, so audio, video, and stream. I'm gonna do what you would normally do, which once you have a device connected like this, is select a cloud endpoint. So I'm going to select that Media Connect endpoint that I told you there, and it automatically grabbed all those parameters from the Media Connect endpoint, all those IP addresses, everything here that's needed to stream to it. And all I have to do is say start and update. And looking back at the device, do it again. It's a rough web app. I'm not a JavaScript expert. Come on now. Let's go. Let's go. It's connected. Okay, so what was supposed to happen is, I think it was just sitting here too long, waiting to go second here. I'm going to blame it on that. Those parameters are sent to the device in the form of a configuration JSON blob, and that configuration lists all of those IP parameters, the port, the encoder parameters, and that kind of thing. And then the device will start streaming, and immediately you'd see the thumbnail in the Media Connect window display light up with the thumbnail from the device. Let me try this. This is the other thing to note is that when you send a configuration to a device, it's using there we go. Now it's starting. I don't know what that was. The configuration that you send is via an MQTT persistent topic. So you can configure a device even when the device is offline. And as soon as the device is plugged in, it wakes up and it says, hey, I'm here, connect to MQTT. Give me the latest configuration that you want from me, and it'll get it. So you don't have to align the time the device is online with when you want to configure it. Okay, so it's streaming now that says active, and we have an active bit rate. And if I look over in Media Connect, you should see a thumbnail of the hockey match. Okay, got it. that was brutal. I have a couple slides after this where what I really want to do is I want to kind of tell you how that SDK works and how the pairing works. It's just sort of technical details on it that I think are going to be interesting. Any questions before I do that, though, on just the demo itself? Yeah. Yeah. I will refer you to Sydney for all product questions.
All right. My question was, are you productizing this?
Are we productizing what exactly?
This whole setup, like being able to do this.
Yeah, so there's three main components here to this whole initiative, this whole project. The first is an open standard for the communication protocol. which is being worked through the VSF, as I mentioned, right? We'll talk about that a little bit at the end, kind of how we see this all rolling out in the industry. The second piece is an open source SDK, right, which is under development and will soon be available with the VSF. When it actually gets integrated, our ultimate aim would be to take Brian's mocked up console that he's showing here and have that available in the AWS Media Connect service, right? And that's further out. That's probably a next year thing before that's available, but that's the ultimate aim. And of course, anybody could take and implement the service themselves if they want to implement something on-prem or in some other cloud provider or whatever. They're certainly able to do that with the SDK. So our aim here is for this to be completely open source, completely open standard, but we want to have a full end-to-end solution for customers. Oh, next.
So is there going to be an API specified, or are we forced to use a SDK?
That sounds like an engineering question. So the specification, I'll just talk about that exact thing, so you'll see that in gory detail. That's the next one. Yeah, it's basically an API specification, so you know how to build the service that can talk to it, and the protocol for what payloads are sent and that kind of thing, and then a behavioral specification for what the client SDK is supposed to do. But we're going to give a reference design in the form of an SDK that's on GitHub. Obviously, people can change it. If they change it and they break something, they can refer to the protocol too. And then I think we'll have other things like a server-side test facility and things like that, so that it makes it really easy for integrators to put it on their device and make sure it's working the way they want to. Okay, I'm going to start the second half of this. I think I have just about 3 slides here. Okay, so I hope you can see that. So the things, that blue thing on the bottom, that's the device. Number 1, that's the SDK that's running on the device. So the device is responsible for launching the SDK process and then talking to it. And that interface, I think I show it in the next slide, is a REST API. So you don't have to integrate it in memory and worry about crashes and stuff like that. It'll be managed separately. That was some feedback that we got from a lot of people we'd shown this to. The second piece is the protocol. So this is in the form of basically a communication protocol for the schema. How does registration work? What are the payloads that are set during that pairing process? And then finally, when it's communicating, what are the payloads that are sent for things like thumbnails and status and configuration and that kind of thing. In addition, the SDK itself will be sending telemetry back to the service. So if the integration has some failure where for whatever reason the device just never updates status, you can tell that that's what's happening. It's not some mystery problem in the SDK itself. So this comes from our pretty deep experience as a service operator, having cloud connectivity to devices. Is you really want to have that kind of connectivity to when a problem happens, you know where it's happening. So that'll be all part of the protocol. What we're going to put up on the GitHub will be the open source client reference design. We'll probably do a client reference design like a FFmpeg encoder or something like that. And then we'll have a reference service endpoint. Either it will be an AWS endpoint or it will be a configuration that lets you build an AWS service with just like one button. It'll deploy the infrastructure needed to do that. So what was happening is that the device was making REST calls to a public endpoint for pairing. Super easy on port 443. It's usually open. And that just needs an outbound open. So the reply to those requests coming from the device going out are usually allowed, very different than trying to tunnel from the cloud through the IP address of the firewall and then have that IP forwarded. There's a whole bunch of problems when you're trying to go the other way. So we don't really have any of those. In addition, MQTT is sort of perfectly suited for this as a bidirectional communication. You hear a lot of things that why don't you use sockets? It's like you could use sockets. You could use a lot of things, but it just solves so many problems. And the way that we're using MQTT is we're using it on top of TLS, and so we can use port 443 and a lot of the modern ways of connecting to devices. This is really it's like the only way I would ever want to do it. This just kind of goes into some detail about the pairing process itself. This was my sort of biggest concern in terms of getting this past AWS approval and AppSec approval for security of things like issuing credentials. And that's been done. Basically, when you start the pairing process, it makes a request. That request returns a code, and that will be returned to anybody calling the API. Anybody calling their give me a code API will get a fresh code, and that code's good for some time limit. And then the very next thing the SDK will do is it'll pull the service passing that pairing code and say, have I been claimed yet? And it'll do that until we get this timeout. But if in that intervening 3 minutes or 5 minutes or whatever we decide somebody's claimed it, then that will get a response, and it will get certs and an identity, and then it'll know that it should just make that MQTT connection. There's a little bit of special sauce in there too. As a human user, 6 characters is probably good enough for security, especially if it's timed out after 3 minutes. Under the hood, there's a giant 256 character code that the SDK is dealing with. So it's very unlikely that anybody requesting certs is going to fake a 6 character code, because I got to fake a 256 character code to actually get the certs. So as long as the device can maintain a secure storage of those certs once it's been paired, then things should be good. And finally, back to the integration model that I talked about before. The SDK needs very little from the device. Right now it's in Python, and it just needs a few very basic libraries like Flask and MQTT. Those are pretty hardened libraries that are under sort of active development. We might do a C++ version of this. We'll see. It's mainly down to like who needs what. I don't think we're going to be too worried about having something so tiny memory footprint that can go on some very old device. Most devices like the encoder I showed you have plenty of memory and an operating system capable of doing this kind of thing. So so the device will launch the SDK process and just monitor it for running and restart it if it dies, that usual thing. And there's about 5 APIs that are to be called. Just connect, disconnect, send status, give me the latest update, send a thumbnail. And any update that comes to it, there's an identifier too that can inform the device that, yeah, here's your update, here's this big JSON blob, but it's the same one I gave you a minute ago, so don't worry about it. So there's IDs associated with it. So all the clever things you need to do to make life like really easy on the integrator or ideas that feed this. Yeah.
So yeah, this kind of comes to the question earlier about kind of what are we going to do, what are we going to productize, and our kind of timeline for this. This is high level and it's dependent upon a lot of things, but yeah, the notion is that we currently have a concept proposal and we're in this draft TR phase that we're working through with VSF. I'd like that to get concluded in 6 months. We'll see how it goes. It is a standards group, right, after all. And then we've already built the concept prototype, and we're going to continue to refine that in the alpha prototype phase, and then ultimately roll that into limited availability. During this time, we're going to start working with partner customers, so our partners and other prospective customers. You can see Brian has already been working with the Osprey team to integrate within their device, but there's several other device manufacturers that we're in discussions with. And then from a Media Connect support standpoint, we'll start development of that as well. And then ultimately, the aim, as I mentioned, is to have sometime early to mid next year have a complete end-to-end solution with customer trials. And I think that's it. You might have, Brian, do you have more? No, that's it. Okay. So anyway, we covered a lot of ground there. So more questions.
Do you intend for this to work with like existing devices like a Link or Elemental Live, for example, or Harmonic or a TEM, whatever?
Yeah, I mean, it's that kind of depends, right? Yeah, the intention is it should be able to work with any of the above. I touched on it early on, right? That when I talked about all the different transport protocols that are available, we sort of went out of our way to make this thing transport protocol independent. And so one of the things we looked at early on is maybe we should just refine the open source SRT library, right? But we had interest from the RIST group and others in using this as well. So yeah, the goal here is for this to be available to be integrated into any device. So could work in any of those. And that's going to ultimately depend upon, like, if they're internal things to AWS, it would depend on those business units and whether or not they want to integrate that and make that work. And the same thing with partners, right? So Harmonic and others, you know, it's kind of up to them, but it's certainly we'd be more than happy. It's more the merrier, right? So the value of this is really the value to the industry. So I initially presented this to the VSF, and yeah, one of our questions was, well, we could just put this out as an extension of the Media Connect SDK and do something like that, but we thought it had broader value, and there was interest in making it a full open source and open specification protocol. And to that end, Mike, you asked about, like, is there just an API that I could just go write my own thing? Certainly, right? So our view was that the SDK is important because when we look at adoption of other things like NMOS in the industry, it went really, really slow because there was no standard open source, a library that anybody could pull from. Eventually things came along there, but it took a long time. And so for rapid adoption, having something that someone can just grab and go, our aim is to be able to get it integrated and working within a device within, a couple of days, right? So minimal effort for integrators. And for folks who've been integrating open source libraries like RIST or SRT, they should be able to plop it down right beside that. And there is some potential talk from RIST and others about integrating this within the next release of RIST, so it's automatically available. We'll see if they decide to do that or not, but our aim would be to make it easy to use, whether it's directly integrated in a transport library or not.
Fantastic. Any other questions, folks? We got one here.
Just making sure that all the communication is from the device to the other endpoint. How does it know? How does it know where to call? Sure. Does it require any configuration to start with?
Yeah. So, sorry, that's a good idea. The question was, how does the device or the device SDK know where to go? In the demo that I showed, I selected AWS. Underneath the hood, that refers to a pretty small little JSON file that has the endpoints for pairing and for getting the certs. That's it. There is no MQTT endpoint that's defined in that. That's given once you get the certs. Included in that package is the device's ID, the certs, and then the endpoint to which it should be connected. And if you think about it, you never really know where in the cloud user is going to be claiming that device, so you don't know what region it's going to be in. And so that region dictates what cloud endpoint is going to be fed to it. So that's a very late binding decision that we do.
That page that you show points to the device itself then?
Excuse, what was that?
That page that you show that you specify AWS, it's in the device itself.
Yeah, so an integrator would integrate the SDK, and on GitHub, anybody who's, let's say, offered a service that it can point to will just simply they'll do a pull request to the repo and add their configuration file, and then again it's up to the user or the integrator of the device whether to delete it or not, whether they want to make it available to their customers. But it all comes through the Git repo.
So all the communication is a claiming kind of model, right? It's from the device up to the...
Yeah, all the communication starts from the device to a public cloud endpoint.
Understood.
Yeah, and then it's either a reply to that request, or in the case of MQTT, it's a reply to the connection to that request.
What's the spectrum of controls that you expose?
That's a good, yeah, we're thinking a lot about that. Thanks. The question was, what are the controls that we plan on providing? So if you think about the status payloads, you can pick an encoder or a camera or a decoder, and maybe from 10 different manufacturers you get 10 different sets of things that they've exposed. And even more complicated, there's what we call complex validations, where having select a parameter of a certain value requires other parameters to have certain values. It's a bit of an impossible problem to try to be everything to everyone, and we don't really want to try to boil the ocean on this. So we'll probably do this in stages, where at first we'll focus on the connection and then like the most popular encoder parameters for an N-channel encoder, maybe decoder as well. And that will serve the needs of things like last-minute changes to to the encode, and then certainly the connection parameters. But if somebody's going to set up something super esoteric and deep, we have another plan that we'd like to do, which is kind of just let them pass anything in the form of a JSON blob, which is, here's my status. I know here's a schema for it, but our service can't really interact too conveniently with just an arbitrary schema. But if somebody wants to send a schema for their arbitrary payload, we could use it to validate whether or not somebody sent a proper configuration and say, you know, that doesn't conform. We don't really know what that payload is or what that device is, but it doesn't work with that schema, and we can throw convenient validation messages in the service. So sort of be like a chew channel thing, just in summary. There'll be a main sort of supported level of controls for most important settings, and then this maybe a sidecar where it's sort of kitchen sink, toaster oven, whatever you want to set kind of a thing.
Last question, I promise.
Yeah.
How do you do the cert rotation, which I'm pretty sure
Yeah.
that the IT infrastructure...
Yes, how do we do cert rotation? So when the device was originally paired, it got an identity and it got X509 certs. Yeah, people like to rotate those things because generally speaking, if they get stolen from the device, there's a window in which they're important or let's say have some value. And so rotating them fairly frequently diminishes the risk. It's a tug of war because if you have, let's say, short expiration on that rotation, what do you do when the device is off in a closet for a week and you've got a 3-day cert rotation period? Like, can you still connect when you turn it on? Because that sort of is the point, right? So we're working through those challenges in terms of the duration and how we handle it. OAuth has a bunch of standards on this stuff too that we could look to. In my opinion, they don't really solve the problem, but the mechanics of cert rotation are super easy. There's a topic that the service sends the new certs to, and the SDK goes, oh, those are new certs. Okay, I'm going to replace the ones that I'm using, and I'm going to be using the new certs. Yeah.
Could you comment on the pipe that is required for the actual transport from ground to cloud?
Yeah, so the question was, can I comment on the pipe and the bit rate that's required? So I presume you're not talking about the video portion. You're talking about the control?
No, the video portion.
Oh, okay.
So it's kind of a side call.
Yeah, so that's really up to you. You can set the bit rate. So if you have a poor connection in a school somewhere, you might want to set a bit rate to 5 megabit or something and use SRT with a big fat buffer and get away with it. If you have more bandwidth, you can set it as high as you want. The cool thing about this is you can do that from the cloud, right? The other thing is you can monitor it from the cloud, so you kind of know when you want to change it, and you're in control of seeing dropped packets, and you're like, okay, I'm going to lower the bit rate, or I'm going to increase the latency. And then, should I spoil alert the future? You can automate this stuff, right? So you can look at historical data, and you can use that to make intelligent choices about latency and bit rate and stuff. Yeah.
Anyone else with questions?
I guess, yeah, I wanted to also expand on, Cassiano, your second question around, kind of parametric control, right? We tend to think a lot about encoders, right? And that's what we showed here with the Osprey device, right? But our aim here is to not have this thing be encoder specific. So if somebody wants to connect a camera, an SRT camera on the ground, to be able to do that equally. And so as you can imagine, it's a slippery slope when it comes to parameter control, right? Like, what if it's a graphics box? Do I want to control graphics layers? Do I want to do these other things, right? And there are other standards efforts kind of underway, multiple, to address that. So yeah, as Brian mentioned, it's kind of like having a whole set of capabilities that are sort of built into the schema, and then have it be extensible for generic things. We as a service will probably support only, again, the most basic things. And really we're focused on discovery, authentication, and connection management, not arbitrary device control, but they could certainly build on top of our service API to do that if people want to do that. Yeah, and monitoring, clearly, yeah. That's a good point.
Any other questions? All right, help me in a great round of applause for Brian and Sydney. Thank you very much.